Hi again. In today's lesson, we're going to study about electrical components. Um, but before that, we can do a recap on our previous lesson. So the previous lesson we studied about the structure of an atom, and we saw that an atom is made up of a couple of elements. We saw that we have electrons, we also have protons, and we also have uh, we we have um, we have neutrons and protons forming the nucleus, this part, and we also have the electrons, which are negatively charged. And we also established that movement of electrons is what causes uh, electricity. The movement of electrons, these electrons carry uh, energy in form of electricity. And other than that, we also looked at a simple circuit. We saw that a battery is able to produce this electricity by usually a battery works by converting this chemical energy to producing electrons, and by producing these electrons, um, uh, and if you connect a wire like this, you're able these electrons are going to move from this negative terminal all the way to the positive terminal. And the battery is going to facilitate that by providing um, it's like a push of electrons from the negative terminal. And now for today's class, which is electrical components, it, it's basically tying to the previous class, whereby in the previous class we looked at a component like a bulb. Like this bulb is an electrical component, but in this case, it's acting more of like a resistor component. So basically, we noticed that since these electrons usually move from the negative to the positive, humans were very clever, and um, we found out ways of utilizing this movement of electrons from this terminal to this terminal, created by that potential difference, which is called voltage. And in the case of a bulb, like a filament bulb, as as we highlighted in the previous lesson, the filament bulb is able to this movement of is able to utilize this movement of electrons, whereby it on the filament we have like some resistance over there. So since the bulb is part of the circuit, as the electrons flow through the bulb, they find this junction, they find this part of the filament, whereby uh, it it's basically resisting a lot of electrons from passing over there. And the result is usually a lot of heat being produced, and also light also as a byproduct. So basically, the filament is designed in a way that it utilizes um, these electrons on but to produce light. Essentially, that's the underlying way a bulb works. But when you zoom in to see what happens at the atomic level, is essentially these electrons, they as they pass through the filament, they knock the atoms, and these like knocking of atoms is going to this knocking of atoms is going to excite the atoms, and then the atoms are going to also collide with other atoms within that small tight space, and hence producing electricity, hence producing light as we know it. And the issue is we also produce heat. This is called a filament bulb, and these kinds of bulbs were not very efficient because they produce a lot of heat, and we want to reduce heat in this case, since our main focus is producing light. So other than that, we have other kinds of components such as an LED. An LED is more efficient. This is what we use these days. LED. It's more efficient kind of way of producing light, but this LED uses semiconductors, which we're going to talk about them in other lessons in the future. But for today, our focus is going to be over here. It's the components that are going to utilize electricity. So, okay. So today we are going to answer this question: what is an electric component? And according to Wikipedia, it says that an electric component is basically is a basic discrete electronic device or a physical entity, part of an electronic system. As we saw, this is the electronic system, or a physical entity. An electronic component is a basic discrete electronic device or physical entity, part of an electronic system, used to affect electrons or their associated fields. Yeah, as we saw that through the movement of electrons, we can now put an electronic component at the center to utilize that so that we can do whatever we want, and that whatever thing we want is dictated by whatever component we're going to put over here. In this case, this component is essentially a filament. Okay, a filament is essentially a resistor, and a resistor produces heat when you're trying to pass electrons. And we notice that as we are told, as the law of conservation of energy says, that energy can neither be created nor destroyed. It can only change form. All right. So in this case, the energy that's was carried by these electrons, it's going to be transferred and changed to light energy, which is useful in the case of our bulb, and also to heat, which in this case it's not required, but it's a byproduct. And we also see energy in a battery stored in form of chemical energy, whereby chemical reactions react. In this case, the battery, you can go and look at it. It's made of zinc and some other things, but essentially the chemical reaction that's occurring inside here is going to produce the electrons. And when it packs these lots of electrons, electrons need to move, and they want to move from this region of high concentration to this region of low concentration. And if you provide a medium, in this case, this wire or circuit, the electrons are going to be forced through. There's going to be a push of electrons through this whole circuit and up to this other side. Up to that other side. And any component that is going to be placed at this center is going to utilize that movement, take advantage of that movement of electrons, and do something. Uh, uh, Essentially, we call it work. Work in physics is it's the measure of energy transfer that occurs when an external force applied to an object causing a displacement. In the case of this bulb, the electrons that are going to flow over here, they are going to knock each other over here. So the electrons are going to carry kinetic energy. And if they reach the filament, they are going to collide with atoms over here. And then that resulting collision of atoms is going to produce light and heat. Again, here, I hope we understand that. So, among the electrical components that we have things like the capacitor, inductors, transistors, diodes, light emitting diodes, and we can see them clearly over here. We have a switch, which I guess it's a component it's an electrical component that it's used to essentially to like break or continue the circuit. Let's just call it that. We also have a battery. A battery is a component that is mostly used to generate the electricity by converting the energy from chemical, which is found in the chemical reactions, to this producing these electronics, which creates the electrons which are moving, they create a current. And an electrical current, we haven't mentioned this, but an electrical current is the rate at which electrical charge flows as part of a point in circuit. Like if in this circuit we have a potential difference whereby this is the pressure. Think of it like a pressure at which this battery is going to eject these, or rather to affect these electrons as they move. The rate at which they move is affected by it's called the voltage, which is the rate at which it's like the pressure pushing these electrons, and that pressure is going to in turn cause the current. Okay, current is driven by voltage, and usually it's opposed by a resistance. Back to this, we also have other components called diodes. I guess a diode, we're going to look more about, to study more about diodes in the future lessons. But overview of a diode, it essentially receives electric current on one side, and forwards it on the other side, but does not allow current to flow on the opposite side. But we're going to look at more about it on other lessons when we study more, when we look more about NPN, semiconductors, and conductors and such kind of things. We also have the light emitting diode. It's just same as the diode, but it emits, it produces light as well. It's more efficient than the filament bulb that we saw. We also have the resistor here. We have seen it as part of the old kind of filament bulbs, which produces light through collisions. And we also have a capacitor. So this is an interesting part, or rather something you can look about these transistor capacitors. They usually, as we can see, we have like a metal plate. Essentially, these are used to store electric, let me call it electric charge, but for a very brief moment. Usually, they're going to be used to stabilize electricity. So if we have some electricity that's flowing through a current and it's not really stable, we can use this capacitor to stabilize that, because it's going to store that. It's like what do we call it? It's like I don't know how to explain it, but I genuinely don't know how to explain it. Yeah, but it's going to hold um electric electric current for a brief moment. Then we also have transistors. We have NPN and PNP, but we're not going to. These are also um, um, important components, and they are going to be very important in helping us understand how computers. They are the basic components that build up the modern computer as we know it. But in this class, we're not going to talk about them. Generally, when in this class, in this class, we generally have to see these components. And basically, I think we are done with our class, since our class was about electrical components, and we have seen what an electrical component is. It's anything that's going to utilize this movement of electrons in any way, by in any way. The simplest being the analogy of a bulb. So yeah, I guess let's meet on our next class.